This video is a review of Year 8 index laws, and it's just me going through a few examples. In the last video I actually went through the actual rules that you need to know and the index laws, but in this video we're going to apply them. Alright, so let's have a look at this first question. This is a question where we've got an expression in a brackets applied to a power on the outside of the brackets. And what you really need to make sure you are aware of is that every part of this expression, so that coefficient, that number at the front, the a and the b to the power of 5 all need to be raised to this power of 3. So that's exactly what we're going to do. The first thing we're going to do is raise minus 2 to the power of 3. Now, you can use a calculator if you want, or hopefully you've got decent skills without one where you realize that raising minus 2 to the power of 3 requires you to multiply minus 2 by itself 3 times. And if you do that, hopefully you will get minus 8. So these two terms, or these two numbers multiply to give 4, and 4 times minus 2 is minus 8. So that's the first part. Next we'll go to my a. That a has no power, but hopefully you can see that any pronumeral, or that any pronumeral without a power is an imaginary power of 1. So this question is looking at that rule from our last video that we said that a to the power of m raised to the power of n is a to the mn. So we need to multiply these powers. 1 multiplied by 3 gives me 3, so we get a cubed. And then we're going to do the same with the b. I'm going to multiply the powers. 5 times by 3 is 15, so we get b to the 15. If you don't know why I'm multiplying, then you've got to go back to the last video, because that explains this. This is just how to carry out the process now that we know the rules. Alright, that's question number 1. Let's have a look at question number 2. Actually, before I move on, just areas where students make mistakes, the minus sign. So forgetting that you're cubing the minus, so 3 times a minus, minus, and a minus. The other place would be forgetting to raise the a to the power of 3. So a lot of times students will just write a cubed. That's a nice another place where students will make an error. So just be careful of these little traps. Alright, question number 2 is looking at multiplication and division, but it's a nice question. It's got order of operations in it. And the order of operations says that if you have multiplication and you have if you have division and you have multiplication together in the one question, what you have to do is work from left to right. So I'm going to start over on this question here and doing the division first, and then I'll move right and do the multiplication. So first thing I'll do when I'm dividing is I'll divide my coefficients. So minus 32 divided by 8 gives me minus 4. And when we are dividing, in our last video, we reminded ourselves of the rule that a to the m divided by a to the n is a to the m minus n. So we're going to subtract those powers. So 6 minus 3 is just 3, so we get m cubed. And n here has an imaginary 1. So if I subtract the 4 and the 1, I'm going to get 3, so we get n cubed. Now, don't forget this term that's on the end. We haven't dealt with it yet. It doesn't mean we just ignore it. We have to make sure we also write that down when we finish our first line of working. We have to multiply by minus 2mn. And the reason why is you've written this equal sign, meaning that these two lines of working should be equal to each other. And if you drop that yellow term and then bring it back randomly in another line, you will have lines of working that are not equal. Alright, let's multiply. So the other rule we recapped in our last video was if you are multiplying expressions with the same base, we add the powers. So this should give me a to the m plus n. A really important reminder is the base does not change. With all of these index laws, my base stays the same. So let's use that over here. First thing I'll do is multiply coefficients. Coefficients are just the number at the front. Okay, regular numbers, we would use regular rules. So minus 4 times minus 2 is 8. And let's go into adding the powers. Wherever you need to, don't forget to put in your index laws. So not index laws, the actual indice or the index of a pronumeral if it has none. So we're going to get m to the power of 4, n to the power of 4. And there's nothing else I can do there. This question is done. 2 more examples to go through. So this one is, again, power of powers, but it's getting a bit more involved. So let's go through raising a fraction. We've got a bit of division there as well with this fraction bar. Let's go through raising everything in the bracket to that power of 2. So I've got that minus 5. I love these colours. Then we've got 4 What else do we have? We've got peas. Let's group them in one colour. And we've got some Q's. So pretty. Alright, so the first thing I'm going to do is raise the minus 5 to the power of 2. So that just means minus 5 times minus 5. And that's 25. And I'm going to do the same to the bottom. If I'm squaring a fraction, I need to square the numerator and the denominator. So 4 to the power of 2 is 16. Alright, next I'm going to deal with the p's. What I want you to notice is that I have p squared on the top, so that's p times p, and I have p to the 5 on the bottom. Now, inside this fraction, actually, I think I'm going to backtrack a little bit. Let's just tidy up this fraction first. Before I even start squaring the fraction, really, what I should do is tidy those p's up. So I want you to notice, we haven't done anything wrong, but let's just go back a little bit. And if I've got a p squared on the top and a p to the 5 on the bottom, what I will do is I'll get rid of all those p's. Notice I've put a line right through them. But I'll just put a little line through the power here, and I'm actually going to swap it for a 3. And I'm doing that because I've removed 2 from the top, so I will also cross out a p squared on the bottom as well. So those, if I cross out, if I have a string of 5 and I take 2 of them out, then I'm left with 3. So I'm going to put p cubed on the bottom, and here as well in the top, I'm going to actually remove that entire q, and then I'm going to remove 1 from this string here, leaving me with 3. So I'm going to get q cubed. That's really the first thing I need to do with this question. Now I'm ready to start squaring everything in the bracket. So this is where my colours will help. I've got a minus 5 to square. I've got a 4 to square. And now all I have is a p cubed to square and a q cubed. So let's go about squaring everything. Minus 5 squared, well, that's 25. 4 squared, that's 16. Now, if I square p cubed, this goes back to the previous slide where we talked about this rule, a to the power of m to the power of n. Let's multiply those powers. So I'm going to multiply this power by 2, giving me 6. But look at where it sits. If it sits in the denominator, your answer will also, or where you place this term will have to be in the denominator. And also here with the q, we've got q cubed, so I'm going to multiply those powers, and I'm going to place my q to the power of 6 in the denominator. There's really not much else I can do with this expression. I can't reduce the fraction. I can't move the p to the 6 and the q to the 6. So this question is finished. All right, this last example just deals with the power of 0 again. We did talk about how any expression to the power of 0... I'm sorry, one sec. Sorry, he just got interrupted by my son. So we'll just keep going now. In the other video, we talked about the fact that anything to the power of 0, any pronumeral or even a number, doesn't matter what your base is, if it's numerical or algebraic, we will get 1. So that's what we're going to use here. So if I look at what's being raised to the power of 0, I've got DE in the numerator being raised to the power of 0, and then I've got D to the power of 0. Don't forget that if it's not being raised to the power of 0, you can't just make everything 1. So really what I'm left with here is 3e minus 3e squared. If I times it by this 1, I'm just going to get 1. So I'm just going to write there 1 so everyone understands that this purple expression to the power of 0 has become 1. And this e, well, it'll also just drop down here. And in the denominator, only this expression will become 1. So I'm really just left with minus 10e times 1. You really don't have to write the times 1s, but I'm just trying to make sure people can see what's happening. So now we're ready to multiply. Let's multiply what's in the numerator. So minus 3e squared times e. Well, that's the multiplication rule would be to add the powers. There's an imaginary 1 here, so minus 3 times 1 just stays as minus 3. And in the bottom, minus 10e times 1 is just minus 10e. Now, some people might think we're finished, but really we aren't. We've got 2 more things to do. You need to be aware of when to tidy. So 2 negatives make a positive. You can't keep them as a negative and a negative. Okay, that would be unsimplified. So we'll go a little bit further and make that 3/10. And also, I can cancel here. I've got a string of 3 in the top, and e times e times e, and in the bottom a single e. So I'm going to cross out that e fully, and I'm only going to cross the power out and write 2. It's really important to be clear with your cancelling. Don't scribble over everything. Just either cancel the entire term or just the power. So I'm going to write in my answer e squared. And that is the final answer. We're done.